Hello, my name is Daniel Lin.
And I am Joseph Litman. Today we will be discussing soil erosion reduction in a scaled model of a hill.
While researching topics to do, we came across soil erosion, which is the process by which arid and brittle soil is carried away by means of wind and water. And the soil is made arid and brittle due to the processes of over-farming or natural causes. We hypothesized that our plants control method would work much better than the man-made control method that we came up with in reducing the erosion in a scaled model of a hill.
So, for our plants method, as previously mentioned, we used chia and bouquet dill because the root structures were fairly good and because they grew quickly enough that they would fit in our time frame. For our man-made solution, we are using 2 dams made of pieces of cardboard folded into a V shape and wrapped in aluminum foil to stop them from getting all soggy and collapsing. We did 2 types of tests, rain and runoff. For the rain, we used a watering can and a strainer to sprinkle water all around our bins with the plants in, man-made and control in them. For runoff, we took the same watering can, ditched the strainer, and just dumped it on the back wall of the bin to create runoff right out. We ran each of these tests 3 times for maximum accuracy. For our enclosures, we used 3 plastic bins with one of the shorter sides cut off, so that any dirt in our hill would just slide right out into our collection chambers, which for those we used aluminum pans.
As a result of each of these tests being run 3 times, we were able to conclude that man-made actually was a better erosion control method than plants, because our data indicated that the lowest amount of dirt had been moved in the man-made model that we created. The process by which we were able to collect this data was once they had reached the aluminum pans, as my partner previously mentioned, we were able to dehydrate them with the use of a coffee filter to get the weight of just the dehydrated items, which was the dirt. Due to these findings, we could actually apply this to multiple different erosion control methods. Like, for example, in the Midwest of the United States, there are a lot of hills similar slopes to the ones that we actually have. We have in our models, and they do not actually have a lot of plants or other structures there to keep soil in place. Most of the erosion in the U.S. happens in the Midwest because the root structures there are basically grass, wheat, rye, other plants that do not have very long root systems, and the potential application of our research could actually be implemented in these regions, which would potentially save thousands of dollars in agriculture every single year. Thank you.